Hello and welcome. In this video, I'm going to complete a series of tasks for MPLS on OcNOS devices. The task is as follows. Provide vpws services for the customer ABC. Now, as you can see, ABC is connected to us using a switch here, but of course, this is an OcNOS device, and as you know, OcNOS devices supports bridging and routing at the same time. In my case, of course, I'm going to use the bridging capability here. What I want to do here is to make sure that this customer, this one, and not this customer, as a matter of fact, this service provider, which we call it OENet solution, is going to act as a giant switch here, which is going to be a transparent device for my customer. And my customer here, this ABC, is going to connect to this giant switch so that it can reach to the other side of its network, maybe on another place, another location inside the country, or even throughout the globe. So this link, which we are referring to right now, which is connected to the switch and the service provider edge device, this is going to be configured either as an access port or a trunk port, which I'm going to show you both of them, and the configuration for them is not so different. But when I have this as access port, the traffic that is going to go through this is not going to be tagged, and it's just going to be for one VLAN, which I'm going to create an IRB interface inside this just to mimic that. The other thing that we are going to do is to make sure that this is going to be configured as a trunk link. When you go with a trunk link, you have some tagged data for different VLANs through this. But for this, you need to specify what VLANs are going to be allowed through this network. So you're going to create this for the customer. But the internal configuration of the service provider is going to be much more important. Here we are trying to implement vpws. Now, vpws, of course, is a virtual private wired service. And when you think of wire, if you have worked with the old technology frame relay, you can just know that this is going to be a virtual circuit, which means that that's going to be created manually. You have to specify the source and the destination, and anytime you need, you have to add the configuration, make sure that some other provider edges are connected to us, and then manage this manual configuration, which means scalability is going to be an issue later. Now, the virtual circuits, like I said, have to be created manually. So let's say that, for example, my customer has two locations, one of them connected to R1, one of them connected to R5. I have to create this virtual circuit between router 1 and router 5 manually. Let's say that then later I have another branch which is here, and let's say that router 3 is my other provider edge. In that case, what I need to do is to create two more links here from R5 and R1 to R3, just to make sure that my customer has reachability to its locations through my other PE here. But again, like I said, scalability is going to be an issue, and we need to just take care of that somehow with some other services, maybe, which we are going to talk about later. Now, vpws, of course, is wired, and which means that this is kind of a connection which is point to point. We have VPMS, which stands for Virtual Private Multipoint Switching or services. And in that case, we have kind of a hub and spoke configuration, which we are not going to cover in our course. And also, we are going to have VPLS, which is kind of a multi-point to multi-point services. Later, we are going to configure it for our customer Alex, and we are going to compare that configuration with vpws, which we have configured by the end of this course, by the end of this video. Okay, so let's start the configuration, and before that, I'm going to examine the internal configuration. In case you have not seen the previous videos, now you are going to have an idea of what is happening here. So in my network, what I have is multiple routers, and my network is configured with MPLS. The links that are marked with red, like this one for example, have two pieces of configuration. One of them is they are configured with MPLS. The command is label switching. One of them is configured with LDP, and the command is enable LDP for this interface. Loopback interfaces, of course, do not have to have any kind of a configuration. But loopback interface is gonna be used for LDP, so I'm going to use this loopback as a transport address for LDP. And these, of course, happened on all of the routers. Some other pieces of configuration are specific to this service, to the provider edge routers. In my case, provider edge routers are R1 and R5 only, but you can have multiple provider edges in your network. What I have here is kind of an IBGP connection between these two. For this IBGP connection, what I have done is I have enabled VPN v4 address family only. I have not configured any IPv4 address family between these two because I don't really need it. So the only address family that I have enabled is VPN v4. And now this is going to, with the MPLS LDP, we are going to have labels generated for the whole network, and then we can just send all the frames that the PE receives here, or let's say packets that PE receives here, to the other side of the network. BGP is going to work in control plane and data plane for us. In control plane, is going to receive the prefixes from other customers, and it's going to convey that prefixes to the other side, and it's going to learn the prefixes, of course, which means that in case our customers has lots of prefixes, we can just kind of minimize the number of prefixes that we are going to learn from the customer, and that is something that service providers do all the time. Okay, so that is the overall configuration. I'm going to show you some part of the configuration router 1 and router 5. The core network, of course, is not going to be so heavily configured. The only thing that they have is MPLS and LDP, nothing more than that. But router 1 and router 5, of course, are my provider edges. So if I just say show running config here, you can see that I might have multiple VRFs for different customers, as you can see. And later we have this router LDP, which is the important piece of configuration. For now, we are going to work with that. And then I have this label switching command and enable LDP command on all of the interfaces which are marked with red, which means that the internal routers here. And also I have my internal IGP for my service provider. I might have some routing protocols which are going to be configured for my customer edge routers as well. But here, this is the internal routing protocol which I am using, which is ISIS in my case. And also the BGP configuration, again, the important part is going to be this part, which is related to the service provider configuration. The rest are address families for each one of my customers. And also I might have some static routes for my customers as well. Okay, it is time to get to configuration, and first of all I'm going to configure switches because I have completely wiped their configuration. So if I just go to here, you can see that there is nothing in there. Let's just log in to switch using the default login credentials, and in here I have Ethernet 1, which the first thing that I'm going to do is to configure it as an access port, and after that I'm going to configure it as a trunk port so that you can see that there is no difference in there is no huge difference in sending the data to the other side. I'm going to create also some IRB interfaces here, which is going to be VLAN interfaces. So let's just go to configuration. In configuration mode, I'm going to give this a host name of switch 6, and then I'm going to create VLANs. The first thing is going to be creating a bridge group, bridge 1. That would be a protocol, and you can give it different types of protocol, RSCP, let's say PVSC, I don't know, MSTP and stuff like that. Let's say we are going to go with the simplest one. So protocol IEEE, and that's going to be VLAN bridge. Then I'm going to create VLAN 10, 20, and 30, and 40, and let's say 50. And that's going to be under bridge number 1, and state is going to be enable. Bridge number 1, actually, not BI. Bridge 1, state is enable. And then I'm going to commit this configuration. So far, I'm going to create VLAN interface, and that's going to be bridge 1, VLAN 10. That's going to have an IP address of 10.10.10.10/24. And let's create another VLAN interface in here, and let's say this is going to be no shot. And it says that it's already no shot, no problem. No such configuration, so this means that you cannot really shut it down. And let's say that I'm going to create VLAN 20 interface, and the IP address is going to be 20. And let's say 6, not 10. 6. For VLAN 10, I'm going to say the IP address is going to be this one, 10.6. So I'm going to commit the configuration. So if I just say show IP interface brief, okay, so this is 6 again. And finally, we have interface ETH1, which is going to be of mode switch port, and it's going to be under bridge 1. Switch port mode is going to be accessing the first part, and then we are going to say switch port access VLAN, maybe VLAN 10 for now. So I'm going to commit this configuration here. So show run. I'm going to copy some of this stuff to switch 8 as well. So I'm going to say OcNOS. That was a mistype. OcNOS. Oh my god. OcNOS. So going forward, I'm going to say enable configuration. Host name is going to be switch 8. And switch 8 is going to have this, and also some VLANs here. I'm going to paste them here. And finally, we are going to have VLAN bridges. Maybe this one, for example. I'm going to say for VLAN 10, this is going to be 8. And for VLAN 20, this is going to be 28. Okay, and finally interface ETH1, and the same configuration from interface ETH1 is going to be copied there. This one. Okay, so not much configuration on the switch side. So the actual configuration goes on RPs, and I'm going to do this in 2 different ways. One of them, it is deprecated, but still I want to show you. And the other one is the new format of doing this. So with the older versions of OcNOS, you would go to this router and start doing some configuration. First of all, you could just create the circuits using this. This part is MPLS, let's say L2 circuit. And then after that, you need to give this a name. Let's say that this is between router 1 and 5, so I'm going to call this, let's say, VC15. Okay, and then you should give this a number. Now the name is locally significant, but the number is important. This number should be the same on both sides. So I'm going to give this a number like 15. So this is going to be the same on both sides. And it says, what is the IPv4 address of the destination? So for my destination is going to be 5555. The loopback interface of the other side. So I'm going to say 5555 and then hit enter. So this MPLS pseudo wire now is going to be created. There are different things that you can configure under that. For example, you can create a tunnel ID. You can create, let's say, group ID, group name, and stuff like that. Nothing is going to be created for me. That's okay. I'm going to just exit and say commit. This part is done. So now that I have created this, The other thing that I have is router LDP. So if I just say show run router LDP, now this part you can see that I have transport address configured here. This pass-through route, do not really care about this one. This is from another configuration. It could stay here, or you can just delete it. You can do something. You can, you see that the LDP sessions that I have created is between these routers on the link level, which means that if I just say show LDP sessions and check this, you can see that it is between the two interfaces here. Now you can create a targeted LDP session between router 1 and router 5. Now what is the benefit of that? That targeted session, if one of these links go down, the other link is going to be there for us to create this LDP session. It is not necessary, but that would be okay. You can just create it. So let's just do that. I'm going to say router LDP, and I'm going to say a targeted session is going to be created between this and 5555. So that part is going to be done as well. And let's commit this part. So let's do the same thing on the other side. I'm going to just copy this one. And on router 5, I'm going to go to configuration mode. And I'm going to create this one, but the destination is 1111. You can see that, like I said, the name is not important, but this number should be the same. So I'm going to create this one first of all, and say commit with 2 M's only. And then what I need to do is to, I wouldn't say I need to do, but let's say creating this router LDP, and under that targeted peer is going to be 1111, and commit this one as well. Now if I say do show LDP session, I should see that this one is right now created. It goes over Ethernet 3, but if I just turn off, shut down Ethernet 3, the session is still going to be there for me, because it will just choose another path to the destination. Okay, so this part is done as well. Now, like I said, so far, whatever you are doing is going to be the same in older version of this configuration and newer version of this configuration. From now on, what I'm doing is going with the older version of the configuration. Then I'm going to remove that, and I'm going to show you the newer version of the configuration. So in the older version, what you would do was to create a service template. You would create a service template, and you would name it something. Let's say, for example, this is ABC, so let's just call this ABC. Under this, you would match different things. Let's say, for example, I can match outer VLAN. In this case, you can match untagged. If you are using this as an access port, then untagged is going to be used. I'm going to say match untagged, and after that hit enter, and then I would use this service template under the interface. How? I would say, okay, this is interface Ethernet 4 connected to ABC, interface ETH4. Then I would say MPLS L2 circuit. This is the command. MPLS L2 circuit. And after that, you would go with the name of the circuit that you created. That was VC15. And after that, you would say service template. And then the service template was ABC. And this is your primary service template. Then you would say that's it. So I'm committing this, and let's see what we have here. It says that, okay, here is a error. It says that configuration vpws interface service template mapping pseudo wire name VC15 depends on interface enable switch port. I didn't configure this interface as switch port on here because I have done it on the other side. So you should really go with switch ports in here. So what I'm going to do in here is to say switch port. hit enter, and then say commit. That's it. So do show run interface EAT4. Okay, now this is the configuration of the interface in here. So do show run, or let's say show run service template. Here is the service template which I have created. I'm going to put it on router 5 as well. So exit and just put it here. Then on this, what did we do other than creating the service template? We just used this line of command. And if I just check, Ethernet 4 on the other side is connected to us. So I'm going to say interface Ethernet 4, switch port, and then I'm going to commit this configuration. So things should be okay. And now we should be able to reach to the other side. So let's check this. The first thing that I want to do is to go to switches. I have created these VLAN interfaces. So if I just say do ping 10, 10, 10, 8, the ping is going through. What if I say 10, 10, 28? It won't go through. Why? Because we have configured this interface as VLAN 10. So what I'm going to do is to change this. And I need to change the service templates as well. So if I just go to here, and I'm going to say service template ABC, exit, service template ABC. This time, instead of saying match untagged, I'm going to say match outer VLAN, and then I can give it a range of VLANs. Let's say, for example, I'm going to say all the VLANs. So that would be from 1 to 4094. Okay. Or I can say from, or let's say, for example, 10, 20, 30, 40, 50. Because I'm a service provider, I'm not going to give this a lot of different VLANs here. Show run service template. Hit enter. So that is what we have here, and I'm going to say no match untagged and commit this. So if I just show it one more time, now we have this. So I'm going to do the same thing on router 5, which is the other side. So I'm going to say service template ABC, no match untagged, but I'm going to use the same command here, match outer VLAN this. And then I'm going to say commit. Okay, this means that now I can just convert this link to a trunk link on switch 6 and switch 8. So I would say here interface EAT1, this is interface name on this. So I'm going to say switch port mode trunk, switch port trunk, and here allowed VLAN list is going to, I'm going to say all, but you should go with the list that is allowed on this. For example, 10, 20, 30, 40, and 50 only. I'm going to do the same thing on the other side. So I go to switch 8, OcNOS, and then I'm gonna go to configuration mode, and I'm going to say interface, this is it, and commit this configuration. What now? Can I ping 10, 10, 10, 8? I can. Can I ping 10, 10, 28? Yes, I can, because that's a trunk. And everything is working just fine. Okay, this is the older version of the configuration. I'm going to show you this in a second. We needed to create a service template, and then we needed to add that service template to the interface. Now, we don't need to do that in the newer version of this configuration. I use the older type because I'm using a physical interface, and the newer version uses a sub interface. And I'm just going to show you the configuration. I don't really need to execute this on this because sub interface for now on my virtualization environment doesn't work. But the actual configuration should be something like this. You just go to, you remove the service template because you don't need it. And what you do is you say interface, for example, each4 dot whatever, 123, for example. Then you would say encapsulation dot 1q123. Then you would say switch port, because this is switch port interface. It should be, of course, switch port. Then you would say access if vpws. And under this, you would say MPLS L2 circuit. Hopefully, I'm just having this. And then the number was 15. And you just hit enter and commit this configuration. If I just run this on my virtual environment, this is not going to work, but on physical environment, that is the way you should go with. And as you can see, I am doing this under a sub interface. So with that, our configuration is going to finish and our service is going to be completed and working as you saw that. I hope this has been informative for you, and see you in next videos.